I'm going to use a ready-made RC circuit. Now, this is a ready-made RC circuit. If you look at this, actually I showed this to you in an earlier lesson. Now, here is the capacitor and here is the resistor. This is a resistor. And you can see the value of the resistance is given as a color code. Now, if anybody is interested in knowing how to read the color coding on a resistor, let me know. I will get back with you. So, this is a resistor. This is the capacitor. And I'm going to connect a power supply across these 2 points. I'm not going to use this cell. That means I will be driving a current through the resistor. Alright, through the resistor. I will connect B to A so that then the current will go through the capacitor. You see, the current will pass through the resistor. Through here I will bridge these two, and then it go through the capacitor and back. That will be the RC circuit. Alright, now let's set it up over here. Now I hope you can see this. Well, this is my RC circuit. It doesn't sit there, so I need to get something to prop it up. Let me see if I can do that. Well, that is the RC circuit. And I have connected the power supply, the battery, across these 2 terminals. And what I'm going to do is, I'm going to connect a voltmeter. Now, here is the voltmeter which you have seen before. Alright, that is the voltmeter. I'm going to connect it. Let me first of all connect it, because these wires are not very friendly, so I need to be a little creative to do these connections. And I also need my glasses to see this. And in the meantime, I have dropped these pieces of wood which was propping up the capacitor circuits because of the stiffness of these wires, you see. Okay, let me see where I need to connect that. I'm going to connect the capacitor, the positive there, and the negative here. So I have now connected the capacitor. Now here are the connections for the cell, and so the current will now come through the resistor. Can you see that? The current will come through this resistor, and I have now connected between these. It will pass through here, go through the capacitor and back to the cell. And since I don't have a meter that will measure the amount of charge, I need only measure the potential difference. When the charge on the capacitor plates increases, the potential difference will increase. So I'm going to use a voltmeter to measure the potential difference across the capacitor. And here is the voltmeter that will measure it. Alright, now let me see. If I turn the switch on to charge and turn on the voltmeter, now I want you to watch how the reading of the voltmeter change. I'm going to turn on to charge and see how the voltmeter reading changes. You can see the voltage across the capacitor plate is increasing. Is that right? The voltage is steadily increasing. That means the amount of charge going into the capacitor plates is becoming, the amount of charge on the capacitor plates is becoming greater and greater and greater. And this is going to take a long time because the battery is a 6-volt battery. and you can see the potential difference is increasing, and it is going to go asymptotically to the maximum voltage. What is the maximum voltage? The maximum voltage is the EMF of the cell, and it will take a very long time to get there. Well, so this is how the voltage increases, and when the voltage increases means the charge is increasing. Now tell me, what happens to the current? The current, as the charging continues, the current is going to decrease. Now that means if I now measure the potential difference across the resistor, what will happen to the potential difference across the resistor? If the current is decreasing, that means the current in the resistor is becoming smaller and smaller. That means the potential difference across the resistor should decrease. As the potential difference across the capacitor increases, the potential difference across the resistor will decrease because the current is decreasing. So let me see, I'm going to remove this connection from the capacitor. You can see the voltage has now reached 4.5, is reaching gradually 6. It will take some time. Now I'm going to disconnect it, and what I'm going to do is disconnect from the capacitor and connect it to the resistor, and let's see how the potential drop across the resistor now look. Now if you watch this, the potential drop across the resistor now is actually in millivolts. It's very, very small. That means the current has become very small. The potential difference is across the resistor is very small. This is not volt, this is millivolt, and it's still decreasing. You see that? The potential difference across the resistor is decreasing, while the potential difference across the capacitor is increasing. So this is what happens when you charge a capacitor. The amount of charge on the capacitor plates increases, thereby increasing the potential difference across the capacitor. And the current in the capacitor decreases. That means the current in the resistor decreases. And that's the reason why the potential difference in the resistor decreases. Well, let me see if I can show a similar thing on the computer. Here we have the RC circuit. This is the capacitor, this is the resistor, and we have a 6-volt battery connected all in series. Now if I turn it on, I want you to watch how the potential difference across the capacitor changes and how the potential difference across the resistor changes. It is animated here and you can watch it. And a graph will be drawn, voltage across the capacitor and current. What would you expect the voltage will behave? Voltage will increase, reach a maximum with time, and the current will start at a maximum value and decay exponentially. The potential drop across the capacitor will increase because the amount of charge increases, the potential drop increases, and the potential drop across the resistor will decrease because the current in the circuit decreases. Alright, watch that as I turn it on. There you are. Potential drop across the capacitor increases, across the resistor decreases, and the charge increases asymptotically, the current decreases. You can see how beautifully depicted in this animation. Alright, watch that one more time and I will turn it off. The charge grows on the capacitor. The potential drop across the capacitor decreases, showing that the current is decaying. So the current in the circuit decays, the voltage grows along with the charge. Okay. If you remember, in the lesson on capacitor, I showed you how a capacitor is charged and then use that charge to light a bulb. So, during the time the capacitor gets charged, the charges flow from the battery to the capacitor, and when you take that charge out, charges flow out of the capacitor to a resistor. The bulb is a resistor. So what is the meaning of discharging a capacitor? How do you discharge a capacitor? Discharging a capacitor is taking out the stored charge on the capacitor plate. In order to discharge a capacitor, we connect the charged capacitor across a resistor. Now this is the same thing I showed you, and the resistor I used was a bulb. So when a charged capacitor is connected across a bulb, the charges flow through